And welcome back to another awesome episode of Domos in the Class. Today, we'll be adding fractions with unlike denominators. This is one whole. So we have a diagram that's fully shaded in and it represents one whole. So our question is, what is the sum of the two fractions below? So our first fraction here, we see that we have how many different parts? Let's count them.
1, 2, 3, 4, 5, 6.
So we have 6 parts in this diagram, and this circle is cut up into 6 pieces. But how many of them are shaded?
1, 2, 3, 4.
All right. So our whole, the denominator represents the whole. How many total pieces do we have? And how many total pieces did we count?
6.
Right. So we have 6 total pieces. And how many were shaded?
4.
4. 4 is the numerator, which would be the top number. So our first fraction would be 4/6. Then we have this one over here. This is another circle that is cut up. So let's count the spaces and see how many total spaces that we have in this circle.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Right. So we have 12 total pieces. Now let's count the shaded.
1, 2, 3, 4, 5, 6, 7.
So we have 7. 7 would be our numerator, which would be on top. So this fraction would be 4/6, and this fraction would be 7/12. First thing we need to do is always understand how much they're worth before we have to do what? Add them together. So now that we know what they're worth, we're going to start out and make our equation so we can get ready to add these two equations together. Well, I'm just going to write the 4/6 here so we can remember that that was worth 4/6 and this is worth 7/12. So now that we know what they're worth, we're going to go ahead and we're going to write this equation. All right, so we have our equation set up. We got 4/6 plus 7/12. So now we have what today's lesson is all about. We have unlike denominators, which means the bottom numbers are not the same. Because the rule in fractions is the denominators has to be the same to add or to subtract. It's different from multiplication and division, but for adding and subtracting, the denominators have to be the same. So we need to set them to be the same. So again, multiplication is key. Why? Because fractions are division. This line means divide. So anytime we're doing division, we always must think the opposite, which is multiplication. So knowing your multiples and your multiplication facts, then we know we have a 6 and we have a 12. They have something in common, right? Because we can get to 12 with 6, right? And we can stay at 12. So that's what we're going to do. Our new denominator is going to be the 12. So we're going to set our denominator for our new fraction at 12 for both numbers. That's the first step we're going to do. Figure out which denominator to take. And now that we figured out that we're going to take the 12, now it's time to change our fractions. So I always like to start with the bottom one. So our first one says 12, and this one says 12. So what do we do using multiplication, Jamir? What do we do if we have 12 and we still have 12 using multiplication? Then what do we do? 12 times what?
12 times 1.
Right. So we put a times 1 right next to the 12. We don't write anything else because we already have our 12 here. And that's how we got it. 12 times 1 gave us the 12. Now, whatever we do to the bottom, to the denominator, we have to do to the top, which is the numerator. So if we times 1 to the 12, which is the denominator, we have to do what? Times 1
Times 1.
to the numerator. So we're going to go ahead and times 1 with the 7. So now 7 times 1 is what?
7.
7. And that goes right over top of our 12. So now we have the same fraction, 7/12, as we did before. But we needed that because it has to say with the 12. Now let's look up the top one. We got 4/6. So 4/6, and now we say we have a new denominator of 12. And we do. So what will it take using multiplication, because this is division, so we need to use the opposite. What will we do? 6 times what can get you 12?
6 times 2.
Exactly. 6 times 2, so we put that times 2 right next to the 6. We don't write nothing else because why? We have our 12 already here, and 6 times 2 equals 12. But like we said, the rule is whatever we do to the denominator, we have to do to the numerator, which means whatever we do to the bottom number, we have to do to the top number. So if we times 2 to the denominator, we have to times 2 to the numerator. And if we do that, we have now another equation that says 4 times 2. And what's that answer?
8.
Exactly. Great job. So that 8 goes right over top of the 12. So now we definitely have a new fraction. We had 4/6, but now we have 8/12. So now we're going to put in our plus and our equal sign for this new equation because now we're ready to add. Why can we add? We can add because we have like denominators. Both are 12s. So now we can move on and continue the problem. So with that being said, if you've watched my fraction videos before, and Jamir, you already know that what do? We have our like denominator. So the first thing we do is we set our denominator at the 12 because we keep it. So our answer is going to already have a 12 as the denominator. So now we just need to figure out what is our numerator. And like we're doing, we're adding. And now that we have both denominators to be the same, we can go ahead and do that. And I like to circle my numerators. Why? So then I can see what is my equation. And my equation is the numbers that circle. So what's our equation?
8 plus 7.
Exactly. 8 plus 7. And do you know that answer?
9, 10, 11, 12, 13, 14, 15.
There we go, 15. So we put a 15 on top of the 12. 15 on top of the 12. Is this something that we know or don't know? Which one, Jamin? Is it something that you know or don't know? What you know? Is it something that you know or don't know? We got 15/12. Sounds right to you?
Yeah.
Yeah, it's right as far as 8 plus 7 is 15 and 12 is the denominator. But something else you're supposed to remember, 15 is too big to be on top of 12.
15 is too big to be on top of.
So then now that makes it a what? When your number's big on top, or your numerator is bigger than your denominator, what do we call that?
Improper fraction.
There we go. Great job. Improper fraction. That is exactly what this is. And don't let it slide past you. When you get to improper fractions, what I like to do is what I'm going to show you right now. So your test or homework, it'll have the choices and you can see what the answer choices are to know what they want. But it's always a thumb rule for me to roll the problem all the way to the end, no matter if the teacher asks me or not. So I know, and you know, that improper fractions means the numerator is greater than the denominator. And when that's the case, we can't leave it like that, or we shouldn't leave it like that. we should go ahead and change it over to a mixed number. So that's what we're going to do. And how do we do that? We put the 15, because remember, this is division. So we put the 15 in our house for division. And we put our 12 on the outside. Now, we got 12 on the outside, 15 inside the house. How many groups of 12 can we get out of 15?
1.
That's right. We only can get one group, because the first thing you should say to yourself is 12 times 2 is what? 24. That's too big. Exactly. So, exactly, we need one group. So we're going to put that 1 over the 5. Not over the 1, over the 5. Because 12 is too big to go into 1. But 12 can definitely, we can get at least one group of 12 out of 15. So that 1 has to be over top of the 5. So now we're going to do the multiplication, which is 1 times 12 is how much, Shamir?
12.
Exactly. So we put that 12 right up underneath the 15 and set up for our subtraction. So we're at 12. We're going to count up to 15.
1.
You're at 12.
13, 14, 15. 3 fingers.
All right. So we put our 3 here. But this isn't whole numbers. So in fractions, we don't leave it there. We bring it up top. We bring our 3. We bring our fraction bar. And we write our denominator from the 12 that we had. And we've created a whole new number, which this is now a mixed number. Why is it a mixed number? Because it has a whole number and a fraction. And that together makes it a mixed number. And the answer is 1 and 3 over 12. Well, actually, I'm not going to leave it there either. That could be one of the choices for the homework, test, whatever you're working. I would say it's still incomplete if I was the teacher, because if you know your multiplication facts, 3 and 12, they have something in common. They share 3s, right? Because 3 times 4 is 12.
Yeah.
Okay. So if 3 times 4 is 12, that means I can get at least one group of 3 out of that 12. So I'm going to divide by 3 from my numerator. And then I'm going to divide by 3 on my denominator. And that's going to give me a new fraction. 3 divided by 3 is going to leave me with 1. And 12 divided by 3 is going to leave me with 4. Because 4 times 3 is 12, right? And 1 times 3 is 3. So the answer should be 1 and 1 over 4. Or 1 and 3 twelfths if that's what you see on the test or the homework sheet. However, the simplest form, and that's the thing about math, the answer should always be in the most simplest form to have the most exact answer. For our next problem, Brian lives 2/3 miles from school. Sean lives 3/6 miles from Brian. If the bus drives from school to Brian's house and then to Sean's house, how far will the bus have driven? All right, so we have 2/3 and we have 3/6. So to 2/3 was Brian and 3/6 was Sean. So we're going to add them together, but the first thing we need to do is what? What do we need to do first?
We have to look at the...
We don't look at nothing. We got to do what first? You can't do nothing.
Circle.
We ain't circling. You can't do anything until they have what?
Something in common.
The same denominator.
The same denominator.
You cannot do anything, two fractions, adding or subtracting, unless they have the same exact number on the bottom. Do they have the same number on the bottom?
No.
So we can't do anything. So what do we have to do? we have to get the same number on the bottom. Isn't that what we're doing today?
Yeah,
That's what we're doing today. Okay, that's what we're doing today. That's the aim. We're adding, right? Fractions with unlike denominators. Are these the same?
No.
That makes them unlike. So we have to make them like. They have to be the same. That is the whole point. That's what we're doing. So we got a 3, we got a 6. What do they have in common so we can decide what the denominator needs to be? What is our new denominator going to be? We got a 3, we got a 6. What can it be? What can we set the denominator to be so we could add them?
You can get a group out of them.
Okay, so you thinking about it right. So we got a 3, we got a 6. So we need to understand that because we can get a 3 group out of 6, that 6 needs to be the denominator that we make both fractions. 1 is already a 6. We need to make this one a 6. So that's what we're going to do. And until we make them both the same, we can't do anything. So we just said we're going to make them 6. So that's what we do. We set our new denominators to be 6. So you follow in your paper, you go across the line like I showed you, right? From where your denominator is at already, follow that line all the way over and write your 6 and put the line over top. Same thing with the top one, where your denominator at the 3. Follow that line over in your notebook, put you a 6, and put your line right on top. That's the first thing that you want to do, is set your denominator. All right, so now that we have both our denominators set for 6, now we have to do the multiplication to make the numerators or the new fraction. So this one is a 6. This one was already a 6. So in multiplication, what did we do to get it to be a 6? This is a 6 already. So what did we multiply this 6 by to keep the 6?
6 by 1.
Thank
6
you.
times 1.
Exactly. 6 times 1, and then it stays a 6. That's how we got it. Don't doubt yourself. And what's the other rule that you know? Whatever you do to the denominator,
You do to the top.
so now what are we going to do to the top?
You put times 1.
Exactly. Times 1. There we go. That's right. Get confident in it. So what's the multiplication?
3 times 1
Is
3.
There we go. We put that right here over top of our 6 right here. So now we have a fraction of 3 over 6. So we're going to do the same thing to the top one. But we have a 3 here, and this is a 6. Using multiplication, how will we get 3 times what is going to give us 6?
3 times 2.
That's what we're doing. Times 2. That's how you get to 6. Exactly. And what's the rule? What we got to do?
But to do the same thing to the top.
So what we multiplying by?
Times 2.
There we go. Times 2. That's right. Sit in it. Know what time it is. Know what's going on. What's the multiplication?
2 times 2.
Is
4.
There we go. Great job. See that? So now we got a whole new fraction. It was 2/3. Now it's 4/6. Okay, so now we got a 6 and a 6. We can do what? We can get ready to add. We had to get that first in order to do anything. When it was like this, 2/3 and 3/6, we can't do anything. But when it's 4/6 and 3/6, now we can get ready to add. All right, so now, since we know both of the denominators are the same in our answer, what's our answer denominator going to be? It only could be one thing. We went through all this work to make our denominators be the same. So in our answer, what is our denominator going to be?
3 over 6.
I didn't say the fraction. I said denominator. Denominator is the bottom number.
It's going to 6.
Thank you. That's what we need to know. We have to first set our denominator at that 6. Because we already know it's going to be a 6. How do we know it's going to be a 6? We just did all this work to make sure it's a 6. That's why. So the first thing you do is you put that 6 down there. Why? Because your denominator is going to be a 6. You ain't even got, that should be less things to worry about. Now is when you get ready for circling. You only circle the numerator. You're starting to confuse it. You only circle the numerator. And why? Because that's where your number sentence come from, right? So you need to see the numbers that you need to add or subtract, depending on what you was doing. But for this, we're adding. So for us to see it clearly with no mistakes, we circle our numerators. So we can clearly see what the number sentence is going to be. What is the number sentence? 4 plus 3 exactly would be the sentence. And what is the answer?
5, 6, 7. 3 fingers.
All right, 7. So 7 over 6.
Is bigger.
All right, then. So what's that?
Improper fraction.
Bling, 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 bling. Correct. I was wondering. That's right. Improper fraction. Great job. So 7 is too big. It's on top of the 6. So we're going to go ahead. We're going to put our 7 inside our house. Because remember, this fraction bar, it means divide. So the 7 is inside the house and the 6 is on the outside. Now, we got 6 on the outside, 7 on the inside. Can we get a group of 6 from 7?
Yes.
And how many groups can we get? Just ask yourself, what is this times 2?
6 times 2.
Ask yourself.
4.
Is that bigger or smaller than the number you're trying to go to?
Bigger.
So can we use that?
No, let's do 6 times 1.
That's how you figure that out, and that's how you know. Now, what's the multiplication?
6 times 1 equals 6.
All right, so you put that 6 underneath the 7. Set up for subtraction. And 7 take away 6 is only 1 left because they're one number apart. Guys, please don't even stress. If you're doing subtraction, it's only one number away. It can only be 1. It's only one number away from each other. Answer's 1. But we don't leave the 1 there in fraction. We do what? We put it up top, and we put our fraction line, and we take our 6, or whatever the number was out there, and that is your denominator. So the answer is
1 and 1 over 6.
There we go. Great job. 1 and 1 over 6 is the answer. Hooray. All right, so for our next problem, this is 1 whole. So we have a rectangle. It's all shaded in, and this representing 1 whole. So the question says, what is the sum? So we have 2 other diagrams, and we have one that is cut up into, let's count the pieces.
1, 2, 3, 4, 5, 6, 7, 8.
So 8 is going to be your denominator. That's how many pieces we have in total. And how many pieces are shaded?
2.
All right, and that's going to be your numerator. So this fraction is 2/8. We're going to do the same thing to this. We're going to count all the pieces.
It's 3 of them.
All the pieces.
1, 2, 3, 4.
That is your denominator. And how many is shaded? Now it's the 3.
3.
And that is your numerator. And that's this fraction. So this diagram is 2/8, and this diagram is 3/4. All right, so we have our 2/8 and we have our 3/4. And as we are learning and have learned, right? These denominators, are they the same?
No.
Nope. So we have to do what?
Make them.
We got to make them the same. And how are we making them the same? We got an 8 and we got a 4. So what's going to be the denominator? What should we set the denominator to be?
To be 4.
How is the 8 going to become a 4?
The 4 is going to become the 8.
That's the only way, because the 8 can't become a 4. 8 too big. So always look at the bigger one. That's one clue right there. And the fact that you know you can get a group of this one, the smaller one, out of there. You can't get a group of 8 out of 4, can you? No, it's too small. That's why it has to go to the 8. So we are going to set our new denominator to be 8. All right? And we starting with the bottom one. So we got a 4. So 4 times what gave us 8?
4 times 2.
Exactly. And so when we do to the what?
We do to the top.
All right, so what we got to do?
Times 2.
There we go. 3 times 2 is what?
3 times 2 equals 6.
There we go. Great job. So we got to do the same up top. So we got an 8 and we still got an 8. So what do we do in multiplication?
8 times 1.
Exactly. And what we got to do next?
We got to do the same thing to the top.
And so what's the we're going to write?
Times 1.
All right. And what's the answer?
Equals 2.
There we go. So now we have a 2 over 8 and a 6 over 8. Both 8s, right? So now we can go ahead and add. Right? And what's the first thing we know when we get ready to add? We just went through all this work to do what? What do we go to work to do? What did we do all the work to do? What did we want it to do?
We have to make them the bottom number the same.
Okay, so what's going to be for our answer? What we going to put down there?
The 8.
All right, now. We're going to set it for the 8. Good job. All right, so now that we know what our denominator is the 8, now it's time to look at our numerator, and we like to circle and circle so we can clearly see what our equation is. And what is the equation?
2 plus 6.
Yep, 2 plus 6. And what's that answer?
8.
There we go. So the 8 goes over top the 8.
8 over 8. So it's improper fraction.
Not as improper. Close. It's something else. 8 over 8.
It's too big.
It's the same number. They same number.
Yeah, it's the same number.
So then what does that mean?
They're equal.
They're equal, so what does that mean? You got 8 whole parts, and you got 8 shaded. So what does that mean? You forgot?
They're all in total.
So then it means what? It means something. You lukewarm. You prancing around.
We have to add.
You don't have to do anything. You have to understand what that means is what you have to do. So 8 over 8, or any two numbers the same over top each other equals what?
1.
There we go. That's what you got to remember. It equals a whole. So it's not a fraction anymore. See? 2 over 8 was a fraction. 6 over 8 was a fraction. 8 over 8, that's a whole. Why? Because the numerator is parts shaded. And also you can say parts of the whole. Right? And the bottom number is the total pieces. Right? Or parts. I'm going to use parts. Sorry, guys. Total parts. Or you could say, if you're not going to say there's the whole total parts, it's just the total parts. I don't want to confuse with nothing else. This is total. This will tell you how many parts is in it. And this up top will tell you the parts that's shaded or the parts of the whole. Either way you can look at it. But they're parts. Now, when they become the same, are they parts anymore? Because they're saying it's 8 in total. So they said, but we got 8 shaded. Once we get the same number over the same number, so you get the same number over the same number, that equals a whole. No more fraction. Okay? And whole means a whole 1. Like a regular 1. Fractions are not 1. Fractions are less than 1. Great job. All right, so for our next problem, Sandra drank 4/5 liters of water in the morning. She drank 7 liters of water in the afternoon. How much water did Sandra drink? All right, so now we have 4/5, and we want to add it to 7/10, but unfortunately, until we get what? What do we got to get before we can add these fractions?
We have to get the same.
That's right, the same denominator, like denominators. That's exactly right. So, what do you think we should go for to be the denominator?
The 10 to go to the 5.
The 10 is going to be the denominator. Great job. So we're going to set our new fraction to have both of them to have a 10 as a denominator. That's the first thing we're going to do. All right, and now that we did that, we're going to look at the bottom one always. So we have the 10 here, and we have a 10 here. So what do we do to get there?
10 times 1.
Exactly. So now what else we need to do?
We have to do the same thing to the top.
So now what are we going to write?
Times 1.
All right, and what's going to be our answer?
7.
All right, great job. And we're going to do the same thing up top, but we have a 5 and we have a 10. So what are we doing?
5 times 10. No, 5 times 2.
Mm-hmm.
10.
5 times 2 gets you 10. Yep. So then we got to do?
Times 2 on the top.
Yep. Times 2. And what's our answer?
Equals 8.
There we go. Great job. And now we can add. So we put our plus and we put our equal sign. And before we go to add, what's the first thing we know we can do?
They got the same.
So then what we going to put for our answer?
A 10.
There we go. First thing we do when we go to add and they have like denominators is go ahead and set your denominator. All right, so now that we have our denominator set at 10, we can go ahead and circle our numerator so we can see our number sentence. Our number sentence is what, Jamie?
8 plus 7.
And what's the answer? You at 8, count up 7.
9, 10, 11, 12, 13, 14, 15.
All right, so we're going to put that right on top of the 10. We're going to put a 15 on top of the 10.
Improper fraction.
There we go. Oh, blink. I was waiting. Great job. Improper fraction. Yes, sir. So we are going to put that 15 in our house and that 10 on the outside. So we got 10 on the outside, but we got 15. Can we get at least one group of 10 or can we get 2 groups? Or how many groups can we get a 10 out of 15?
10 times 1.
Right, because if you do 10 times 2, that's going to be 20. And 20 is too big. So that's why you always want to automatically just shoot in your head. What times 2? Whatever the number is, times 2. Or times 3. Whatever it is, see what you got to do. But no, you was right. Times 1. And 1 times 10 is how much?
1 times 10 equals 10.
All right, so we put that up underneath the 15. Now we have 5. Take away 0 is?
0. Equals 5.
There we go. And we don't write the other 0, so we have a 5 left. And because in fractions, we put our 5, we put our 10 underneath, right? But like I'm going to tell you again, your homework may say the answer is 1 5 over 10. I'm telling you that that's one of the answers. One of the answers is 1 5 over 10. And when it comes to your test or your homework, whatever the choices is there, that's the one that you use. But also you need to know, moving forward, that's going to change because 5, you can still get one group of 5 out of 10. Well, you can get one group of 5 out of 5, and you can get 2 groups of 5 out of 10. So if we did that, and if that's confusing, we have 5 over 10, And if we divide that by 5, and whatever we do to the top, we got to do to the bottom, remember? All right, then. So 5 divided by 5 will give you 1. 10 divided by 5 will give you 2. So that would be 1/2. So it could be either 1 and 5/10, or 1 and 1/2. Both of those are the answer. But the real answer to me is the 1 and 1/2. But the real answer is whatever's on your homework, whatever's on your test. That's the real answer because your teacher is grading it and she decided what she wanted. But in math, the simplest form from 1 and 5/10 would be 1 and 1/2. All right, so now that we got our denominator set, we're going to circle our numerator. And what's the number sentence?
3 plus 2.
And how much is that?
5.
All right, good job. So we're going to put that 5 over top to 4. All right, so we have our number line. And they say that's where he lands at. So, no, that's starting at 3/4. Okay. So to add a half, how will we know where is he going to be at? The easiest way to do it is to just solve it the way we've been solving. So let's go ahead and do that. We got a 3/4 and we got a 1/2. So we notice, everyone sees that there are 2 different denominators. So we need to make those the same. So what do you think the denominator is going to be, Jamia?
The 4.
Exactly, the 4. Great job. So now we look at the 2. What do we do in multiplication to get to 4?
2 times 2.
There we go. And what we do to the bottom, we do to the top. So what are we writing up at top?
Times 2.
And so what's that answer going to be?
2.
All right. And the top one, we got 4, and then we got 4. So what do we do in multiplication?
4 times 4.
What?
4 times.
We have a
1.
4. That's it. So I don't understand why you got this concentration look on. Like, what are we doing?
4 times 1.
And then?
And then we have to do it to the top. Times 1.
Thank you. What's the answer?
3.
There we go. Don't make it hard. Please don't make it hard. Please, guys, don't make it hard. Don't. So now what? What do we know? We can divide, right? Because we have what?
Because we have them the same.
Exactly. So what's in our answer going to be? What's our denominator going to be?
4.
There we go. That's the first thing we set. So go ahead and set that denominator. All right. So now that we got our denominator set, we're going to circle our numerator. And what's the number sentence?
3 plus 2.
And how much is that?
5.
All right. Good job. So we're going to put that 5 over top to 4.
Improper fraction.
There we go. Bling, 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 bling. I'm just going to put an IF. Improper fraction. Yep. So we're going to put that 5 in our house. We're going to put the 4 on the outside. Can we get a group of 4 out of 5? How many groups of 4 can we get out of 5?
4 times 1.
Thank you. And what's the multiplication?
4 times 1 plus 4.
There we go. And the subtraction, we 1 number away, so it's just 1. The remainder, there's no remainders. There's still fractions. So that 1 go there, and that 4 goes there, and that is your answer. And what is the answer?
1 and 1 over 4.
1 1/4. So now, to show that on the number line, because if you pay attention to the number line, there's 1 space, 2 space, 3 spaces, 4th space here. 1 space, 2 space, 3 space, 4 space here, which means this number line is set up in 4s. And we have 1 1/4. So that's 1 whole. Here's our 1 whole, right? 1/4 is going to be right here. So 1 1/4 is going to be right here. And this is where he lands at on the number line. He started here, and he ends up there. And that is that. Well, just to be clear, I want to make sure that you understand that each one is a fourth. So this first one is 1/4. This would be 2/4. This would be 3/4. One whole is 4/4. Remember that? Yes. That's how we get it. That's how we get the 1, because it's 4 over 4. So 4 over 4 is what gives you the 1. And then this right here is going to be 5 over 4. And 6 over 4. And 7 over 4. And 8 over 4. And that's 5 over 4 is what we got. Didn't we get that? Didn't we get 5 over 4?
Mm-hmm.
Right here, right?
Mm-hmm.
And that's right there. So that's where he landed at on the line. All right, so for our next problem, we have 7 over 12 plus 1 over 6. So we can't quite plus right now. Why can't we add them?
Because they don't have the same.
Exactly. Good job. So we need to make sure that they do. We need to get them with like denominators. So what's our denominator going to be?
6 and 12.
Right. It cannot be the smaller number.
It has to be a bigger number.
It always has to be. Okay? Mm-hmm. And it has to be what they share in common. But it has to be the bigger one because 12 can't become 6. It's too big. All right? So it's the 12. So we're going to go ahead and set it at 12. So we're at the bottom one. So from 6, what do we do in multiplication to get to 12?
6 times 3. 6 times 2. Times 2. And then we have to do it to the dot.
All right, times 2.
Times 2 equals 2.
All right, 2 over 12 is our fraction. What are we doing up top?
Times 1.
All right, times 1 is the same number. Don't make it hard.
Then times 1.
There we go.
Equal 7.
Now we can add. Now we put that and that equal. Good job.
Okay.
So now that we got the same denominator, can we add?
Yes.
So what's going to be our denominator?
The 12.
There we go. And that should be the first thing you do once you change them. All right, so now that we wrote our denominator, let's circle the numerator. And what's the number sentence?
7 plus 2.
Yep, 7 plus 2. And what's that answer?
9.
Yep, 9. So 9 goes over 12. So for this problem and any problem, I'm always going to remind you that reducing is something that you should be doing, whether your teacher asks you to. And because you're learning, then you need to learn. And 9, right, and 12, they have something in common. And I'm just going to tell you, they got 3s in common, right? Because 3 times 3 is 9.
Mm-hmm.
And then what you can do, 3 times what is 12?
3 times 4.
Exactly. So what we're going to do is we're going to divide, right, by 3 on the top and divide by 3 on the bottom. It's got to do both. And 9 divided by 3 is going to give you the 3 because 3 times 3 is the 9. And 12 divided by 3 is going to give you the 4 because 4 times 3 is the 12. So this is what the answer should say in the simplest form. But if your test or your homework or whoever you're doing math for, they have 9/12, then you go with the 9/12. But always work it out to the 3/4. And then you have both answers to look at your choices and see which one they want. But the simplest form is 3/4. So that would be the answer, 3/4. See? 3/4. All right, so for our next problem, we have 3 over 10 and 2/5. So we do want to add, but first we need to do what before we can be able to add?
See, are they the same?
Not see if they're the same.
They're not the same.
Right. And then so what do we need to do? We got to make them the same. Exactly. That's what we got to do. So now what's going to be our denominator?
The 10.
Exactly. Good job. So we're going to set them at 10. And we at the 5 now. So what did 5 take to get to 10?
5 times 2.
Mm-hmm. And then what?
And then times 2.
Mm-hmm. Equals?
Equals. Dot equals 2.
Equals what?
4.
Thank you. Now what we doing up top?
Same thing.
Huh? We got 10 and 10. How do we get there?
Times 1.
Mm-hmm.
Then times 1.
Mm-hmm.
And that gives us times 1 gives us the 3.
Yep. So now we could add the plus and our equal sign. And we have the same denominator. So what's going to be in our answer?
The 10.
Yep. Good job. Great job. Right, so now that we got our denominator set, we are going to circle our numerators. And what's our number sentence?
3 times 4.
Not times.
3 plus 4. 3 plus 4.
Is how much?
7.
Yep. And 7 is not too big. So the 7 will sit right there. And they have no 7. 7 is a prime number. Only way you can make 7 is 1 and 7. So there's nothing, you can't get no groups of 7 out of 10. They don't share anything in common. So the answer is going to be 7 tenths. All right, so for our final problem for today's lesson, we have 1/2 and we have 5/8. Yep, we want to go ahead and add, but we already know we can't add. Why we can't add?
Because they don't have the same.
Exactly, they don't have the same what?
They don't have the same bottom number.
Bottom number called what?
The numerator.
Nope.
The denominator.
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 Right, we want to use those vocabularies so we can know to express what we're saying and know what we're saying. So when we hear it, the top is called what?
Numerator and the bottom is in denominator.
There we go. Great job. Great job. So we don't have the same, what's it called?
We don't have the same denominator.
All right. So we don't. So now what do we need to do?
We have to make them the same.
Okay, and how are we going to do that?
We have to times.
We got to decide what number is going to be the denominator.
8.
Yeah. So that's what we do. Okay, so we're going with the 8. Now what we do?
And now, multiplication. 8 times 1.
Yep.
And times 1 will give us 5.
All right.
And times 2.
Times what?
No. Two times 4. 2 times 4.
All right, great job.
Then times 4. And now 1 times 4 is 4. 4 over 8.
All right, so we got 4 over 8, 5 over 8. They both got 8, so we can now add. And what's the first thing we're going to do now that we got our denominators the same?
You have to circle the top number.
What's the first thing we're going to do now that we have our denominators the same?
Now we're to put the 8.
Yep, we set our denominator first. We always put in the total amount that we have first. We don't put in shaded first.
Then we circle them.
Exactly, that's the next step. But make sure you stay in order, because if you jump out of order, you'll get it wrong. There's an order. So the first thing we do is set our denominator. Good job. All right, so now that we have our denominator set, Now we're going to go in and circle our numerator. What's our number sentence?
4, 5 plus 4.
Mm-hmm. And what's that?
9.
Yep. 9 over 8.
9 over 8. And now it's a improper fraction.
All right. Bling, 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 bling. Bling, 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 bling. IF. All right. So we're going to put that 9 in our house. We're going to put our 8 on the outside. We got 8 and we got 9. Can we get a group of 8? How many groups of 8 can we get out of 9?
You can get 2 groups. You can get 1 group.
Which one is it? Because you're saying different stuff, so I don't really know now.
2 groups.
See? What's 2 groups? 2 times what is what? Tell me what your 2 groups equal. Tell me. Tell me what the 2 groups equal.
8 times 2 is 16.
So if you said that already to yourself, then
You have to do 8 times 1.
yeah, we got to do 8 times 1. It's not 8 times 1. We're doing 1 group, then we're going to do 8 times 1. So 1 times 8 is 8. And they are 1 number away. That's the 1. There's no remainder. We put the 1 up here, and the 8 becomes our denominator. So what is the answer?
1 over 8.
Yep, 1 and 1 over 8. That is the answer to the problem. Great job. So we've made it to the end of the video, and I hope you guys enjoyed it. Always remember, it's not what you don't know, but what you're willing to learn.